now write the general forms of the single and joint photodetection signals for a quasi-classical state. We will use the Heisenberg representation introduced in Lesson 5 of Quantum Optics 1. Recall that in this representation, the state of radiation does not evolve and keeps its value at the initial time. So here we take it equal to a quasi-classical state alpha L that does not evolve with time. In contrast, the operators do evolve with time, in particular the electric field, whose positive frequencies expression, E plus of R and T, is reminiscent of the classical expression with the complex amplitude replaced by L operator times the one photon amplitude. Since E plus involves only the destruction operator, the quasi-classical state alpha L is an eigenstate of E plus L, with an eigenvalue equal to the mean value of the electric field, E plus class, which we have calculated in section 3. Note in passing that the mean value of the electric field can be readily calculated in the Heisenberg representation. We are now ready to obtain the photoelectric signals since they involve E plus applied to the quasi-classical state, a quantity that we have just calculated. The final calculations are especially simple, and I recommend that you do them yourself. Consider first the single photodetection signal, of which I recall the expression here. Using the result just obtained, you will immediately find that W1 of R and T is proportional to the square modulus of E plus classical. In fact, it is exactly the semi-classical expression of the photoelectric signal for a classical field E plus classical. Can you find a similar result for the double photodetection signal W2, of which I record the expression here? Since its quantum expression is written in the normal order with E plus 2 times on the right-hand side, you will obtain the product of the square moduli of E class at R1T1 and R2T2. The results here are remarkable. For a quasi-classical state, alpha L, the photodetection signals are strictly identical to what would be obtained in the semi-classical model with a classical field equal to the quantum average of the field in the quasi-classical state. In particular, the double photodetection signal W2 is equal to the product of the single photodetection signals at the same points and times. This is in contrast to what we had found in the case of a single photon, where the double detection is null, although the single detection signals are both different from zero. In order to avoid a misunderstanding, it is important to realize that this property remains true even for extremely weak quasi-classical states with alpha smaller than 1, that is to say, with an average number of photons less than 1. We will come back to this point later.